Today we're going to learn how to simplify algebraic expressions. So what we're going to be learning how to do today is to identify parts of an algebraic expression and to write an algebraic expression in simplest form by combining like terms. So all of this contains a lot of vocabulary to start, such as algebraic expression for one, like terms. We're also going to add on to that constant term. So we're going to start out with vocabulary, but by the end of this lesson you guys are going to know how to simplify algebraic expressions to their simplest form. So let's get into the vocabulary. Alright, so in an algebraic expression you have terms. Terms can be a number, a variable, or a product or quotient of numbers and variables. So examples of terms: 1 is a term, 4x is a term, y is a term, 2m to the third power is a term, -8 is a term, -x over 2 is a term. So all of these are terms here. In an algebraic expression, you have terms that have variables, and you do have terms that are constant terms, meaning they do not contain variables. And we're going to look at the definition of constant in a second. But in an algebraic expression, in an algebraic expression, terms are separated by plus or minus signs, never by multiplication or division. Once numbers and variables are being multiplied, such as in 4x, that is one entire term. Now, algebraic expression is something we did define earlier in the year, but just for a reminder, algebraic expressions are expressions containing variable terms. So for example, 4x plus 7 is an algebraic expression. Once I have an equals sign and something on the other side of the equals, it's an actual equation. But an expression is just a statement of, such as 4x plus 7. What makes it algebraic is the x. The statement 4 plus 7 is actually a numeric expression because it doesn't contain variables. Now, in expressions, sometimes we have like terms. Terms that contain the same variables that are raised to the same power are considered like terms. So 5x squared and -3x squared are considered like terms. Those are terms that can be combined. So if we try to think of other like terms, 4 and -2.5 are like terms because they're both number terms. They don't contain variables. X and 2x are like terms because they both contain x. And let's say m to the second and 3m to the second are like terms. Alright, let's get into some more vocabulary. A constant is a term that does not contain a variable. So this is just a number. So in the expression that we looked at earlier, 4x plus 7, 7 is the constant, meaning it is a number that stays the same, it never changes, it never varies. 4x can change or vary depending on what x is. If x is 1, then that term becomes 4. If x is 2, then that term becomes 8. Simplest form. An expression is in simplest form when it is replaced by an equivalent expression having no like terms or parentheses. So there should be an is there. So an example of simplest form would be 4x plus 7, because I do not have any like terms. There are no parentheses, and this is equivalent to 2x, for example, plus 2x plus 7, but in this case I see that I have two like terms, so this is not in simplest form, but this is. Okay? Alright. So, a reminder, this is already in your notes from now, not Friday. I apologize for that. So I'm going to cross that out. But if you're looking at an expression, the most important thing to do to begin is to identify the parts of the expression, and then this slide is actually in your textbook. So when addition and subtraction signs separate an algebraic expression into parts, each part is called a term. Remember that the numerical factor of a term that contains a variable is called the coefficient of the variable. So we had talked about this before, but in the term negative 4x, this is called the coefficient. And we know that that means that we multiply x by whatever x is by negative 4. And you know that the number portion, like the 12 there, would be your constant term. So like terms contain the same variables to the same powers. So for example, 3x squared and negatives of an x squared are like terms, so are 8xy squared and 12xy squared. But 10x squared z and 22x z squared are not like terms, because in these two terms, the x and the z are not taken to the same powers. All right, so a term without a variable is called a constant. We know that because that's a number term. Constant terms are also considered like terms. So if there was an extra number in this expression here, we would say that that was also a constant. So in this expression here, we have 3 terms, we have 1 constant, we have 2 like terms. All right, so the first example we're going to look at is done for you. So identifying the like terms, the coefficients, and the constants in the expression 6n minus 7n minus 4 plus n. So when I look at this expression, I know that I have 4 terms that are separated by minuses and plus signs. Those terms are 6n, negative 7n, negative 4, and n. And the reason that I know that the 7n and the 4 are negative is because I always take the sign that's to the left of the term. So I know the 6n and the n are positive. Well, for one, the n has a plus in front of it, and we know whenever there's no plus or minus, we take the positive sign. In this situation, I have 3 terms that are alike, 6n, negative 7n, and n. I have 3 coefficients, 6, negative 7, and 1. Those are going to help me whenever I start to combine my like terms. And I have 1 constant value of negative 4. So now you guys try. Maybe pause the video before I give you the answer. Alright, so in this expression here, 3x minus 5 plus 2x minus x, I have 4 terms. Those terms are 3x minus 5, or negative 5, 2x, and negative x. I have 3 like terms, and those are 3x, 2x, and negative x. Those like terms are all variable terms, and they all have coefficients of 3, 2, and negative 1. And I do have a constant term of negative 5. Now, if you're having a hard time with the signs, and trying to figure out what sign goes with what term, very common issue that we have, we can use our rule of keep, change, change and turn this into an addition problem. So we know we're going to keep this first number, add, change this 5 to a negative. Since that's a plus, I don't need to do anything, but I'm going to keep the 2x, add, make the x negative. So then I can see where I get that negative 5 and that negative x from. Okay? All right. An algebraic expression is in simplest form if it has no like terms and no parentheses. Sometimes you're going to need to use the distributive property to combine like terms. We're actually going to do that later on in another lesson, but today we're just going to be simplifying to simplest terms. So I take a look at the expression 4y plus y. I know that there are 2 terms, and I know that they are actually 2 like terms. So I can combine them. So whenever you're combining like terms, to combine like terms, you add the coefficients. So I'm going to write that down as a note. To combine like terms, you add the coefficients. So in this case, since I have 4y plus 1y, I would add my 4 and my 1, and the simplest form of this would be 5y. That would be how I simplify it. Now you might look at that and say, but how do I know that's 5y? Well, 4y, that's just 4 y's put together. And one more y is going to give me that 1y. So I'm putting 4 y's with 1 y. That gives me 5y. So it's just easier for me to add the coefficients and get straight to the point. Okay, so let's take a look at another one. Write 7x minus 2 minus 7x plus 6 in simplest form. So I know here that I have 4 terms, and I know that I have 2 pairs of like terms. So in this case, I know that, and I'm going to use underlining to help me. I know that 7x and negative 7x are like terms. I'm going to use a different underline for negative 2 and positive 6. So I know my straight lines are going to go together, and I know my squiggly lines are going to go together, but then I cannot combine straights with squiggles. Okay? So I'm going to rewrite this expression to regroup my like terms. So again, let me first turn it into an addition statement. So that's 7x plus negative 2 plus negative 7x plus 6. Now that it is an addition problem, I'm going to use the commutative property to switch those two, giving me 7x plus negative 7x plus negative 2 plus 6. Now I'm ready to start working towards simplest form. Well, if I add the coefficients of 7x and negative 7x, that's going to give me 0x plus. And if I add negative 2 to 6, that's going to give me 4. So my final answer is just going to be 4. Because 0 multiplied by anything is 0, 0 by the additive property of 0, 0 plus anything is that number itself. Now I'm going to put 2 more up that I'd like for you to try without me, so pause the video at this point. And now let's get some answers. So 6n minus n, I know that there are 2 terms, and those 2 terms are like. So I'm going to turn this into an addition problem. That's going to be 6n plus negative 1n. Anytime I don't have a coefficient, I know there's a coefficient of 1 there. So adding my coefficients, 6 plus negative 1, that's going to be 5n for final simplest answer. Let's go to the next one. 8z, I'm going to turn it straight into an addition problem, plus z plus negative 5 plus negative 9z plus 2. I know I have 2 pairs of like terms. I have my z terms and I have my constant terms. I know straights can go together and squiggles can go together. So I'm going to regroup my problem. 8z plus z plus negative 9z plus negative 5 plus 2. Well, 8z and z, that's going to be 9z plus negative 9z plus, and I'm going to go ahead and combine those. Negative 5 plus 2 is negative 3. Well, 9z plus negative 9z, that's going to be 0z plus negative 3. And I know that 0 plus any other number is going to be that same number itself, so my final answer is negative 3. All right? Okay, now a word problem. So the cost of a set of DVDs after a 25% markup can be represented by the expression C plus 0.25C. Simplify the expression, then determine the total cost of the DVDs after the markup of the original price of 40%. So I know if I'm looking at the expression C plus 0.25C, I know that I have 1C and 0.25C. So again, I add my coefficients to get 1.25C. So if $40 is the cost, that's going to be what I replace C with. So 1.25 multiplied by 40, that's going to equal $50 for my final answer. That's all they're asking you to do in this problem. All right. Manfred buys some boxes of cereal for $4.85 each and the same number of bags of pretzels for $2.90 each. write an expression in simple form that represents the total amount spent. So in this case, if I say that B equals boxes or bags purchased, I know that $4.85 multiplied by B is going to give me the total cost for all the boxes of cereal, and I know that $2.90 multiplied by B is going to give me the total cost for the number of pretzels purchased. So in order to simplify this expression, I'm going to multiply add 4.85 to 2.9. So in this case, this would actually be 6. I apologize, it's actually going to be 7.75B would give me the cost for all of the items that he purchased. Alright, let's get to that problem of the day. For tomorrow for class, I want you to just identify the terms in the first two problems, the terms, the like terms, the coefficients, the constants. And then for the last two, I want you to simplify the expressions and write them in simplest form. Have a good night, and I'll see you tomorrow.